Well, hello guys, Mr. G here, and we're going to be making another video for the grade 10 related to transverse wave. This time we're going to be solving two questions just to practice what we learned before. So the first question, both of the questions are taken from previous question papers, and the first question said like this. The diagram which follow is a graphical representation of a water wave moving from left to right across the page, and that is the diagram that you can see there. Supply level for each of the letters A, B, C, and D. So let's find out each of them what it represents. Now, what is A? Let's start with A here in the diagram. A represents the amplitude. A represents the amplitude of the wave. Now let's go to B. What does B represent? B is the distance between a crest and a crest, and this is the wavelength. So this one is the wavelength. The wavelength. C. What does C represent? C represents a crest. This is the highest point. Okay, what else do we have? D. Where is D? D is right here, and that is the position of rest. This represents the position of rest. And that is the first question, just completing what is the meaning of each of those, or what is the name of each of those points they're giving you there. What is the amplitude of the wave? Obviously, if you see that one, you can see here that the amplitude then will be this distance here. This is the amplitude that we measure before the amplitude. And then if we answer here, we don't have to answer down, it's not necessarily the amplitude. I'm going to write A is going to be equal to 20. Now 20, what is the graph here given in? It is given in centimeters, as you can see there on this side there. So it is 20 centimeters. That is the amplitude. Now determine the wavelength of the wave. Okay, now to determine the wavelength of the wave, note the following. The distance here is given in centimeters, and be careful with the graph. You can get confused very easy. What we have here in the x-axis is not distance, it is time. And that is an important detail here to notice. This represents time, very important detail. So the distance is given here top by this length here. So this is the distance, and they are telling you that from the starting point to the final point, the distance is 100 centimeters. So we need to know first, before we carry on, how many waves are represented here. So let's do that. And as always, let's first go through here and then represent one wave, only one wave. This here represents one complete wave. Okay. Now from there, you have another wave from there all the way up until this one here. That is another wave. And then we can see here that still another little piece. Now note the following. There is missing. If you move here, you will have the rest of the wave. So what we represent here is just half a wave. So how many waves are there? And we're going to write it here. There are 2,5 waves. So how are we going to solve that question? And this one is question 1.3. Question 1.3. What we have? We have that 2,5 wave cover a distance, or have a distance of 100 centimeters. You can see there is 100 centimeters. Now the question is, one wave, how many centimeters will it be? And you are going to do cross product here. So you have here, you have that 2,5x is equal to 100 multiplied by 1. and x will be equal to 100 divided by 2,5, and the answer is 40. So it means that the wavelength is going to be, wavelength, we're going to write it with the correct symbol, is equal to 40 centimeters. I hope you understand. If you didn't, please rewind the video in that part so you understand what I have just done here. Okay, now why did I substitute one wave? Because one wave is the wavelength. Wavelength is the length of one wave. Okay, so that was question 1.3. Determine the wavelength of the wave and show how to arrive. Determine the frequency of the wave. Now, the frequency of the wave. Note that what you have here in the x-axis, as we did mention before, is time. So you know the time for the waves. And if you know that, this time here, which is the time for the first wave, is what we call period. Alright? That is the period. So the period is 2. So if you come here and you do question 1.4, this is question 1.4, determine the frequency of the wave. You know that frequency is equal to 1 divided by period. You don't even have to write data here because it's very simple. 1 divided by 2, because the period is the time for one wave, and that is 2 seconds shown in the graph. So this one is equal to 0.5 hertz, and that is the question 1.4. Question 1.5, calculate the speed of the wave. So 1.5, question 1.5, let's do it in this side here. 1.5, let's see what we have. What data do we have? We have that frequency is equal to 0.5 hertz. We have that period is equal to 2 seconds. We have that wavelength is equal to 40 centimeters, but we cannot work in centimeters. So if you convert, you have 0.4 meters. So what is the best formula we can use here? And this is really simple, guys. Speed is equal to frequency multiplied by wavelength. So if you substitute here, this is 0.5 multiplied by 0.4. Speed is equal to 0.2 meters per second, and this is the final answer, guys. This question was really easy and simple. You can always, that is the advantage of having videos, you can rewind, you can stop, you can go back and forth. Okay, so that is the first question we are going to be doing, which is already done. Let's go to the next question. The second question, the question states the sketch below is a graphical representation of a transverse wave, and you can see here the representation. 2.1, indicate the following by using the symbol supplied, wavelength. Now remember, what is wavelength? Wavelength, first of all, is the distance between two consecutive crests or two consecutive troughs. In this case, this is wavelength. Okay, and there is another point, B to F. Remember, wavelength, the definition, the correct definition for wavelength, the more complete one is the distance between two consecutive points that are in phase. So either of those represent one wavelength. So all you have to write here is say that wavelength is either AD or BF. Those two represent the wavelength. Then they say what indicate what is representing the amplitude. Remember, the amplitude is the distance from rest position to a crest or from rest position to a trough. So in this case, the amplitude will be represented by this distance here, and you can represent it anywhere, but the thing is, here is where you only have the letters. So this is amplitude. Amplitude, that is representing the amplitude. So you have to write here DE. That distance there is what represents the amplitude. And the final one, position of equilibrium, which is the same as position of rest. And the position of rest is going to be represented in the graph for the union of all these different point from one extreme to the other. This one here is what represents the rest position or position of equilibrium. Rest position or position of equilibrium. So if you write something relating to the graph, we can write that this is the union of B, E, F. All those points they represent the rest position, okay, by indicating the following using the symbols applied, okay. So all that represent the rest position, B, E, F, okay. Now the next one, 8 complete wave passes a point A in 2 seconds. If the distance between A and D is 0.2 meters, calculate. Now A and D is a wavelength, so this one is 0.2 meters. They are giving you the wavelength of this specific wave, and they are telling you that 8 complete waves pass a point in 2 seconds. Calculate the frequency, calculate the period, and calculate the speed of the wave. Now, what is frequency? Frequency is the number of waves in 1 second. So to calculate frequency, this is question 2.2.1. To calculate frequency is equal to 1 divided by period. You need a period. Now you don't have the period. What we have, and we are going to use the same approach as in the previous question. We have that 8 waves. Remember, period is the time for one complete wave. 8 waves takes 2 seconds. 2 seconds to pass from that point to another. 8 wave passes a point in 2 seconds. In one wave, which is the period, one wave, how long it will take in seconds. We're calculating the time for one wave. So you are going to do cross product. Remember, we did the question just now in activity in question 1. What do you get here? You get that 8x is equal to 2 multiplied by 1. X is equal to 2 divided by 8, and x is equal to 0.25 seconds, and this is the period. So this number is going to be substituted there to calculate the frequency. Then frequency is equal to 1 divided by period, which is 0.25, and when you calculate that one, the answer is 4. So the frequency is 4 Hz. And that is the answer for question 2.2.1. Now question 2.2 is calculating the period. And the period was calculated here before, guys. So we don't have to recalculate it. This one is question 2.2.2. We did calculate the period. However, if you manage to do it in any other option, you can say that period is equal to 1 over a frequency. Period is equal to 1 divided by 4, and that will give you that period is equal to 0.25 seconds. So this is another way to calculate period, because remember, the period and the frequency are the opposite ones to each other. Now calculate the speed of the wave, and then with that one we are going to finish this question. It's very, very simple. So question 2.2.3. Let's see what we have. We have that the wavelength is equal to 0.2 meters is given to us. We have in that the frequency is equal to 4 Hz, and we have that the period is equal to 0.25 seconds. So we have everything. What formula is the best that can help us in this question? Speed is equal to frequency multiplied by wavelength. Okay, that is the best one I found. However, note the following: everything is converted there, so you don't have to convert. Okay. So when we substitute here, we have the speed is equal to 4, which is the frequency, multiplied by 0.2, which is the wavelength, and the speed of the wave is equal to 0.8 meters per second, and this is the speed of the wave. Saying that, guys, this is the end of these 2 questions. I hope it helped. I hope you understand the questions are not that difficult, but in the question in the exam will be more or less the same. It won't be much more difficult than this. So if you understand this one, you are sorted for the upcoming exams. But thank you for watching. Time up. If you think it helped, you can ask questions, suggest, and as always, subscribe to the channel. Mr. G here. I'll see you next time.